Hello class. In this lesson we're going to learn how to find missing angles with the use of triangles. So let's do some more vocab. So here we have an isosceles triangle, and it's important to note that the definition says at least two sides of equal length. That means that an equilateral triangle is also isosceles because it has three sides of equal length. And when we have just two congruent sides, we call those two sides legs, and the other one will be the base. And note that the base doesn't have to be on the bottom. You could turn this triangle however you want. The base could actually be on the top of the picture. So just the word base doesn't mean bottom in this case. It just means the side that isn't congruent to the other two. And here we have terms for all different types of triangles. You should know these. And we can classify triangles two ways. You can either do it by its sides or by its angles. And so definitions of the angles of a triangle. Here you have it. And another thing you might see, when it's not ambiguous what the angles are, we can just call them angle A, angle B, and angle C. We don't have to call it angle BAC. So really, depending on the picture, it's gonna that might be different. You know, if there's multiple angles at A, then you will have to use all three letters. But in this case, you could just call it by one letter. Exterior angle. So basically what this definition is saying is that if you extend a side of the triangle, that angle that you get on the outside, that's called an exterior angle. And you can do that with any of the three sides. So I'd like you to try this. Get out a piece of paper and draw a triangle on it. And I'd like you to rip the corners off and see if you can arrange them like you see in the diagram over here. Just want you to try that. And now I'd like you to make a conjecture, so a statement of what you think is going to be true about the sums of the interior angles of a triangle based on what we did here. So you might have already known this. And based on the picture, it looks like those three angles form a straight line, so we know that they add up to 180 degrees. And so that's called the sum of the interior angles of a triangle. So if you'd like a picture, here you have one. So no matter what type of triangle we have, those will always add up to 180 degrees. And here's another one, similar idea. But now I'd like you to draw an exterior angle and only rip off A and B. And then line them up over here. And what do you think now? What do you think is a property of exterior angles that we can apply? So it looks like that those two angles you ripped off, A and B, line up exactly with that exterior angle. And that is the property we have here. The measure of the exterior angle, so here angle 1, is equal to the measure of the sums of the opposite interior angles. So for angle 1, that would be angles A and B, because they're not adjacent to 1, and they're on the inside of the triangle. We could also call them remote interior angles. So all it's saying is that you're ignoring this angle that's adjacent to over here. You're just adding up A and B to give you angle 1. In an isosceles triangle, what do you know about the base angles? They are congruent. They're equal in measure. So remember, the base doesn't have to be on the bottom. You could have this going sideways, and B and C would still be considered base angles. And in an equilateral triangle, the measures are always 60 degrees. Why is that? Hopefully you can reason that through. We know that there's 180 degrees in total inside the triangle, and there's three angles of equal measure, so 180 divided by 3 is 60. And so now let's apply some of those properties of triangles and parallel lines that we've been working with. And I would like you to try these, see if you can find the numerical answer, and I'd also like you to write down the names of the properties that we used to solve them. And so now you've tried that, I'll show you how I solved this problem. So here's my diagram. I extended those parallel lines. And let's see. Well, I knew that over here, these are alternate interior angles. So this one is also 39 degrees. And we have adjacent angles that form a straight line. So these add up to 180. So that must be 46. And here's my work for that. I did 180 minus 95 minus 39, gave me 46. And now we have this triangle here, and we know two of the angles. We know 46 degrees, and we know this right angle is 90 degrees. So A will be 44 degrees. And so to put that in words, here we have it. Those are the properties that we used. Really, we shouldn't, I don't like how the book says this. They said linear pairs form supplementary angles, but we have three angles here, so you really shouldn't call them a pair. You might want to call them adjacent angles that form a line. I think that's a better term there, because pair implies two. Okay, what about this one? So I extended those lines. And really, this is just alternate interior angles. There's nothing else going on there. Right? Just angle B is 58 degrees. You could have, maybe the isosceles triangle threw you off a little bit, but you really didn't need to use the fact that it was isosceles to figure out what B was. And here we have one. Going to have to apply more properties than the previous ones to solve this. So give it a shot and write down the steps you followed. So in this one, I said, all right, well, I have an isosceles triangle here. All right, I have two congruent legs. That's what these symbols mean. And so if that's 42 degrees, then the base angle over here must also be 42 degrees. And we know that in this triangle, the interior angles sum to 180 degrees. So this vertex angle is what it's called, 96 degrees. All right, well, how does that help us? Well, we want to figure out what C is. And actually, we have an exterior angle that's a little hidden. If we put these two angles together right here, these two angles, right, labeled in red, those two are an exterior angle to this triangle, this upside down triangle. So if you add them together, x plus 12 plus 96, that will be equal to the sum of the two remote interior angles. And so now we do some algebra. All right, simplify. Move your x's to one side, move your constants to one side, divide by 4, and you get 25. But we're looking for C, and so we still got some more work to do. Well, you know that if we add these three angles together, add their measures together, you will get 180. So now I'm using C as a variable, but remember C is really the name of that angle. So we want to give our answer as the measure of angle C is equal to something degrees. So we solve this equation, and we end up with 47. So the measure of angle C is 47 degrees. And here we will have all of the steps that I verbalized. All right, in this lesson, we learned how to find missing angles using the properties of triangles. Thanks for watching this video.